So now let's talk about transcendental functions, integration of transcendental functions. There are some selected functions that are said to be transcendental functions, but actually they name, but it doesn't really mean that they're difficult. Well, first of all, start with the fact that sometimes you see questions that look like this. I'll start with this first one. It says that 1. You talked about integral of 8x over 2x minus 1 dx. There are different these are rational numbers. Good. Now, the integration of rational numbers which are transcendental. Now, you have 8x divided by 2x minus 1. Good. The first thing is, you consider the fact that if you have a problem like this, the 2x minus 1, you assume it to be the value of u. So you take it as its function. Let u be equals to 2x minus 1. So if you are having this, so it shows that the u over dx is equal to 2. So what you are having now is that the u over dx equals to 2. And what it also means, that is to say, what it means is that the u itself is equal to 2 dx. Good. Now, when you have that, it's easy for us to consider the fact that dx now is equal to du over 2. So, wherever we find the f dx, it's still the same value as du. Good. Now you have 8x divided by 2x minus, and we have this to be u. So because of that, the dy dx of this automatically becomes du over 2. So wherever you have this value, it is du over 2. So now, from here, already this value here is u. So you just consider. So 8x over 2x minus 1 dx now give you a value of 8x. Give you a value of 8x over u. And you know very well that the value of x is now du over 2. So automatically you are having values like this, taking this out. And now you are having a value of integral of 4x du over u. Now, having something of this nature, you discover that because you have a value of u up and down, it gives you automatically the value of 4x in u. And that gives us 4x in, and the value of u again is 2x minus 1. So you have the end of that. So first of all, represent u to be equals to 2x minus 1, then du, then you find the value of dx to be du over 2 from this expression, and automatically you represent the values. When you bring this in, this cancel it, that gives us 4x du, and because the u at the top, the u beneath, the u divided by u, that leads us to what we call in u, which is called incapacity logarithm. Good. But sometimes you consider questions that has to do with Neperian logarithm, but this is incapacity logarithm. So always remember the u, that gives us in u. Now we'll consider question 2. And the question 2, we are having the integral of 8x cubed minus 2 divided by x raised to power 4 minus x plus 1 dx. Now, the first consideration comes from the fact that what we are having beneath is going to be the value of u. So you have let u be equal to x raised to power 4 minus x plus 1. Now that you have that, it's easy for you to say du over dx will give you 4x cubed minus 1. 4x cubed minus 1. Now, from here, the y dx of x raised to power 4 is 4x raised to power 3. The y dx of x is 1, and the y dx of 1 is 0. So you're not adding the 0. So from here, if you cross multiply this, it shows that the value of dx now, surely du becomes dx into bracket 4x cubed minus 1. And it shows that dx now has a value of du divided by 4x raised to power 3 minus 1. So wherever you see the value of dx now, here, which is dx, it can now be replaced with du divided by 4x cubed minus 1. Let's replace that. So from here, it's easy for us to see the value 8x cubed minus 2 over x raised to power 4 minus x plus 1 dx can now become a value that is like, if you take this out, you observe that this value 8x raised to power 3 minus 2, then you have here, for this now becomes integral of 8 x raised to power 3 minus 2 divided by x raised to power 4, which is now the value of u, times whatever we have as dx, which is now du over 4 x raised to power 3 minus 1. Now, it's simple here. Now, whatever you have as dx now, it's now du divided by 4x raised to power 3 minus 1. That is the value of dx. Now, here you still have your normal value, but the value of u, don't forget, it's now represented as x4 minus that. That's why I'm placing u here. So you have du here, you have this value. Now, it's simple. So what you will now tell yourself is, these two values here, do they look alike? Are they related? Is there something about them? There's something about them. This value here, I can change it now to become, it can now become 2 into bracket 4 x raised to power 3 minus 2. Can have that divided by u times du over 4x raised to power 3 minus 1. So if you look at the values, 2 times this will still be this, 2 times this, so there this become 1. 2 times 1 is 2. 2 times 4x cubed is 8x cubed. So this we cancel this because of the multiplication strand. So from here you have 2 now times this, that become 2 du over u. And don't forget, the 2 comes out. When the 2 comes out, it becomes 2 integral of du over u, which automatically becomes 2 in u. And that becomes 2 in, what is our u again? The value of u is x raised to power 4 minus x plus 1. So the in stands for the in kappa's logarithm. So that's for question 2. Now we can consider something else. Always remember, the first thing you do is to represent the value of u. Find the dy dx of du dx. After that, you replace back into the integral. You are done. Good. Now, you can take this out and consider question 3. Now, considering question 3, that will become question 3. I'll have statements like, oh, this is Neperian. That becomes log x plus 1, then x plus 1 dx. Now it's easy for us to consider the fact that let the in complex value here is that let u be equals to log x plus 1. Now, if that's the case, du over dx will become is equal to 1 over x plus 1. So if you are having that, if you cross multiply, it shows that du is equals to dx over x plus 1. And it shows that dx is equals to du is equal to du into bracket x plus 1. Now, wherever you find the value of dx now, it is now du into bracket x plus 1. So let's replace that. So therefore, this expression log x plus 1, which is this dx, and dx now is now representing something else. It's not du into bracket x plus 1. So that becomes multiplied by du into bracket x plus 1. Now, considering this will surely cancel this. When that cancels, don't forget what I represented this value to be. This value here, log x plus 1, is now represented by u. So automatically, it now gives us something of this nature. And what would that become? It becomes the fact that this becomes integral of u times du. And that gives us integral of u du. And since there is no value that is a variable, there's no variable value, there's no constant value, a variable, but there's constant value. So you're not taking anything out. So because you're not taking anything out, that automatically becomes 1. You can consider that as the value. That becomes 1 in u. So, and that becomes 1, because you have 2 logarithms now, you don't need to consider that. That automatically becomes log x plus 1. So you can consider it in this form. So whether it's in Kappa's logarithm or Neperian logarithm, the log is equal. So you have log x plus 1 as your value. So that's for question 3. Let's consider question 4. So from that value, it's easy for us to consider the fact that the Neperian is still the same thing as. So if I am u, I'll just do what? From here, from this value here, it's easy for me to tell myself that the integral of this automatically is going to give me, the integral will give me u, it will give me u squared over 2 plus c. So if I'm having this, so when I replace the value of u here, automatically it becomes, it's a direct value now, it becomes 1 over 2 into brackets, whatever the value of u is, the value of u itself is log x plus 1 plus c. So I can have something like this. So if you integrate the value of u, it will give you u raised to power divided by 2, and automatically the 2 itself is also 1 over 2. Whether you're multiplying it with or add is 1 over 2 or divided by 2. Now that's that. We'll consider question 4 now. Still under rational functions of integral values, which you can call them transcendental functions. Now, let's consider this. Question 4 now. For question 4, you're having a value of x over x squared minus 2, and you have your dx. They are still rational. Still rational values. So automatically from here, I can look at this and just tell you, let u be equals to x squared minus 2 is the rational value that is there. So from here, du over dx automatically gives me 2x minus 1. So if I cross multiply, I'll have du to give me dx into bracket 2x minus 1. Funny enough, if you find d, take subject of formula of dx. Dx here becomes du divided by 2x minus 1. So I have this as a value. So if I have this as a value, it's easy for me to consider. I'm taking u somewhere. Now when you get to this point, dx, therefore this value here, x divided by x squared minus 2 dx, automatically changes to become the integral of x divided by u times this value here, which is the value here will give me automatically. From here we have 2x, so this is automatically 0 and this is 0, so we are still having 2, so this is 2x automatically. So because the y dx of a constant is 0, so here dx here becomes du all over 2x. Okay, good. I'll take it all over again. From here, integral of x divided by x squared minus 2. Beautiful. Let u be equals to x squared minus 2. So du over dx will give us 2x, because the y dx of 2x squared will give us 2x. So, and the y dx of minus 2 is total 0. So du is equals to dx by you cross multiply. This go cross multiply. So dx, subject of formula, gives me du divided by 2x. So if du divided by 2x is now my value. So anywhere I find the value of dx, I will always represent it with the value du over dx. So now I take my du over dx. I now replace it here where this value is. So when I replace it, having dx there also means times dx. So when I place that value there, so I still have my x here. My x squared minus 2, which I represented as u, is not u, which is u. So times, what did I get from dx? Dx equals to du over 2x. So I have this. So now x will cancel x. So when x cancel x, what I'm now left with is something like this. Is du over u. And don't forget, this is the same thing as 1 over u du. And if I want to find the integral of 1 over u, you can also write this as integral of u minus 1 du. So it depends on the simplification. 1 over u, reciprocal. So if I take the integral of this, the integral of this will become u minus 1 plus 1 minus 1 plus 1 plus c. That will give me u plus c. And automatically that will give us in u plus c. And in u plus c, what is the value of c, of u? That's x squared. So that's in x squared, so I have x. So normally I'm supposed to have, I have x, so I'm supposed to have 2 u here. So automatically my u is supposed to come in from, my u is supposed to come in from 2u. That becomes minus 1 minus u du. So that's supposed to give me a value of 1 over 2 times 1 over 2 times u. 1 over 2 times u plus c. So here I'll have 1 over 2. That becomes u over 2 plus c. So automatically this gives me 1 over 2 in 1 over 2 in u plus c. And that's 1 over 2 in whatever u is. The value of u is x squared minus 2 plus c. So I'll have this. So please remember, from here, x this, that. So you cancel, that's 2. So you have du over, that's 2 du now, is equals to 1 over 2u du. So 1 over 2u du, 1 over 2 mathematically can also become 1 over 2u, the same thing as 1 over 2 times 1 over u. So this is 1 times 1 is 1, 2 times that's 2. So that becomes 1 over 2 times u raised to power minus 1. So that's why I changed this to. Okay, so 2 raised to power minus 1 is also 1 over 2. So 1 over 2 times u. By the time you take the integral of u, taking the integral of u will become u minus 1 is equals to u minus 1 plus 1 minus 1 plus 1. That becomes u. Because 1 plus 1 is 1, that's raised to power u. So automatically in u. So from there, it's easy for us to consider the fact that we've done thing of this nature. That becomes x squared minus 2. So we'll consider the next question. Our next question is question 5, which is very, very simple. Now we'll consider the last question, which is the 5th question. The 5th question, that's question 5. That gives us integral of 4x minus 2 divided by x squared minus x plus 1. Then we have dx. Now, the complex value represents u. So you have u to be equals to x squared minus x plus 1. So du over dx is equal to 2x minus 1. Because the ydx of x squared will give me 2x, the x of x will give me 1. Good. Now if I have this, automatically, if I cross multiply and make dx the subject, the value of dx will now become, this going here, then it become 2x, probably du over 2x minus 1. Du over dx equals to 2x minus 1. So by the time you make dx the subject of this equation, what you get is du over there by using the word cross multiply. Dx becomes du over 2x minus 1. You can work that out. Now after having that, it's easy now. So anyway, we'll find the value of dx here now. We'll represent it by du over this. So let's rewrite this. So that becomes 4x squared minus 2 divided by x squared minus x plus 1 dx. So it now becomes, what now become? Integral of 4x minus 2 divided by u, x squared minus x plus 1 was represented as u. So dx now times dx. What is the value of dx again? Dx is du over 2x minus 1. So now dx has been replaced, du 2x minus 1, and the value of x squared minus x plus 1, which is u, has been replaced. Now if you look at this carefully, you observe something, that there is a relationship between this value and this. And what's that relationship? It's simple. You have 2 into bracket 2x minus 1 du divided by u into bracket 2x minus 1. What I did was that I multiplied them together. This times this times this. But don't forget, 2 is common between this, and that's why I brought the 2 out. So if you look at this now will cancel this. So automatically, that leads us to the fact that it becomes an integral of du of 2 du over u. Now, taking that value out, if you take the value out, this is the same thing as 2, the integral of u raised to power minus 1 of u raised to power minus 1 du. And depends whether you write it like this or like any of them, you're correct. So that gives us 2 in u, because you're having the value as a fraction or raised to power minus 1. So that gives you 2 in u, the encompass value. So the encompass value now becomes 2 in, what's the value of u? The value of u is x squared minus x plus 1 plus what? C. That will be the integral value. So when you have this, it gives you an estimator. So remember, you represent a complex value with u, you take it down. After taking it down, you get the value of the x. After the x, you replace it here and replace the value of u. With that, you bring it down. When you get to this place, du over u, the value of the numerator and denominator, they are the same, so automatically give us the incapable value of it. So in u, 2 in u plus c. The value of u is replaced and you get plus c, and that is the integral value. Now, we're done with that. Let's consider exponential functions of transcendental functions. Transcendental functions can be exponential too. And exponential functions, in differentiation, we'll consider the fact that the dy dx of e, the of e x dx is equals to ex. If you remember this, the dy dx of ex is still equals to ex. So I'll tell you now for free that the integral of ex dx for free is also ex. So the integral of eu du is also equals to eu. So always remember this for that exponential. The e stands for the exponential function. Now, if for example you are given a question like, say, evaluate, maybe you are given the integral of I'm giving the integral of 4e 2 raised to power x dx. You're given something like this. It's easy. What do? First of all, you let what? U to represent 2x. After letting u to represent 2x, the normal thing we do, du over dx will give us 2. So what will dx become? Dx now, if you do subject of formula, dx now becomes what? Going here, that becomes du over 2. I believe you understand this. So if you just cross multiply, this go here, and you have the divide both side by 2, that becomes dx equals. So anywhere you see the value of dx now, it's not du over 2. Beautiful. Always remember that. So from here now, it makes it easy for us to say, okay, this value now is now 4e 2x dx is now the value of 4e u. The reason why we're using u at the top of e is because we have represented u to be equals to 2x. So anywhere you see 2x now, it's now u. Now please, what's the value of dx now? The value of dx now is now du over 2. So let's continue. So from here, it's easy. We can just say 2 cancel 2 here. So we still have what? Integral of 2 eu du. I have a dot there. That stands for multiplication. So if I take the 2 out, which is one of the rule of integration, become eu du. If you integrate eu du, that becomes 2 into bracket. The y dx of eu, what will it be? The y dx of, the integral of du is what? Is also eu. The y dx of eu is what? Still the same thing. So what would that become? That becomes eu plus c. So that gives me 2. That becomes, okay, from here we've not replaced that, so that's 2. So that gives me 2 into bracket e. The value of u is 2x plus c. So by the time I open the bracket, I have 2e 2x plus c. So I have this, simple. So remember, the first thing, you take the value of the complex value and represent it as u. So after that, you find the value of dx, which is not du over 2. You replace it into this statement. And what you get, when you get to this place, you find the integral of eu. And what the value of eu is, gives you this. So we're done with this first one. We can take another question. They are simple. So let's consider another evaluation. Let's consider another evaluation. Another evaluation is when you are asked to evaluate. You have to evaluate probably the integral of maybe e 3x dx. You have something like this. So the first thing, let what? U be equals to 3x. So what is that? Du over dx is equals to 3. So you cross multiply. What will dx become, class? That becomes du over 3. You see now? So just take this value of dx and replace it. Don't forget this is still u. So you remember now, it becomes e 3x dx. Now become, what would that become? That become the e 3x now is now eu, because x stands for u. And the value of dx becomes du over 3. Simple. Now from here, you discover there's nothing to cancel, unlike the first question. So there's nothing to cancel. You take it as a fractional number, which is 1 over 3. Now look at it. From here you have something of this nature. 1 over 3 is the fraction here. You take it out. That is the rule of integral, taking a constant out of the integral side. So from here you have eu du. So the eu du, what is the integral of eu? Is still the same thing as eu. So you have 1 over 3, which is the constant. So you still have eu plus the value of c. That gives me 1 over 3. That eu itself, what would it be? E, what do we represent u to be? That's 3x. So that will become 3x plus c. So the final value now becomes e3x over 3 plus c. That is the value of our integral. It's simple, and probably you too, you are less busy, you enjoy yourself with the integral of 8 e 3x dx. And you can also enjoy this 8 1 over 4 e x 1 over 4x over 3 dx. Good. So you can have something like this. So with this, we've come to the end of transcendental functions. Though we have other complex transcendental functions like the trig functions and co. But for now, we'll stop here. And in further classes or further level, we'll talk more about complex analysis in transcendental functions. Thank you very much. I'm still your maths instructor. We'll meet in other classes.